Aeronautical decision-making is an ongoing process, requiring a continuous assessment of what's happening around you, or more commonly called situation awareness. To help you get a feel for some of the decisions you might make during a flight, this program presents some situations that you may encounter. The first example takes a pilot on a cross-country flight from Grand Island, Nebraska to an important job interview in Cheyenne, Wyoming. Because the mind is very complex, it would be impossible to cover every thought process. However, you'll see how your personal attitude, level of pilot skill, ability to identify risk and handle stress all combine to help you formulate decision-making strategies. You'll also be given an opportunity to see the results of some of these decisions, which you personally might or might not make.
Good morning, Cessna 52241. I'm going VFR from Grand Island, Nebraska to Cheyenne, Wyoming. I'd like a standard briefing.
Okay. High pressure in northwestern Wyoming continues to dominate most of your route. However, the weak cold front that was expected to pass through Grand Island by 1300 Zulu is just now moving through southwestern Nebraska. Grand Island is currently 7,000 scattered with high cirrus. The forecast calls for 5,000 broken, visibility 10 at 1400 Zulu when the front passes. North Platte indicates 8,000 scattered, visibility 20, and is forecast to remain the same for the rest of the day. Cheyenne is currently 10,000 scattered, visibility 15, and they expect clear skies by 1700 Zulu. So the front will bring some clouds into your area, but good VFR conditions should dominate your route. The current winds aloft, Grand Island 6,330 at 15, 9,330 at 18, 12,320.
With the known winds, you can now add the estimated times en route between checkpoints. Then complete the performance calculations for the airplane. After completing your performance calculations and filing your flight plan, you begin preparing the airplane for the trip. As you know, the pre-flight inspection is one of the most important parts of your flight preparation. While you're still on the ground, you have plenty of time to assess the airplane's suitability for making the flight. Now you're ready to go, but are you? Before you start the engine, let's take a quick look at your evaluation of the airplane's airworthiness. If you had looked closer at the fuel container, you would have seen that water is present in the fuel. Although finding contaminants in your fuel is about the risk you'll take if you don't assure they're completely removed before takeoff. Another potential problem area is the oil level. The dipstick shows you have 5 quarts of oil, which for the airplane is the minimum amount. However, for extended flights, such as a cross-country, you should fill it to 7 quarts. Just remember that as the pilot in command of an airplane, you're responsible for deciding whether it's airworthy or not. A careful pre-flight inspection helps you determine its condition. Now that you're confident the plane is airworthy, you're ready to start the engine.
Grand Island Airport information, Bravo. 1345 Zulu weather, temperature 47, dew point 33, wind 340 at 10, altimeter 3005, landing and departing runway 35. Advise ground control on initial contact, you have information, Bravo.
Grand Island Ground, Cessna 52241 at the General Aviation ramp, ready for taxi, 35 with information, Bravo.
Cessna 241, taxi to runway 35.
Cessna 241.
Cessna 241, we can get you out a little sooner if you want to take off at the Alpha 2 intersection. There are 3,500 feet available.
Ground, Cessna 241, that would be fine.
Grand Island Ground, Cherokee 8228 Yankee at Foxtrot, ready to taxi 35 with information, Bravo. Cherokee 28 Yankee, taxi to runway 35. Alpha 2 intersection departure, 3,500 feet available. Cherokee 28 Yankee requests full length. Roger 28 Yankee, taxi to runway 35. 28 Yankee.
For some reason, the Cherokee pilot did not want to use the intersection takeoff. Are you still sure you do? There could be several reasons why the Cherokee pilot declined the intersection takeoff. One of these might be that he is closer to the approach end of the runway. For you, the most obvious concern is that there is enough runway to complete the takeoff. During your pre-flight planning calculations, you determined that you needed only 1,440 feet to take off and clear a 50-foot obstacle. So, with 3,500 feet available, there's plenty of runway for a safe takeoff.
Grand Island Tower, Cessna 52241, ready for takeoff, runway 35, Alpha 2, VFR westbound.
Cessna 241, fly runway heading, cleared for takeoff, runway 35.
Cessna 241.
Your decision to depart from the runway intersection does not involve a definite right or wrong answer. This decision depends on your level of pilot skill, the airplane's performance capability, and the runway itself. It also includes weighing the risks. What if you lost power right now? Remember that water which you almost left in the tank? If the engine fails at this point, the runway behind you doesn't do you much good. You are now established in cruising flight and are about an hour-and-a-half west of Grand Island. It's important to maintain a constant awareness of your situation while en route by performing a thorough scan for traffic and by monitoring the various gauges and instruments to ensure everything is operating properly. Your situational awareness is important because accidents are often caused by a chain of events rather than one particular occurrence. This means that if you fail to monitor the flight's progress, you might not detect a problem or a change from the desired situation. Or, if you make a bad decision, further problems may begin to compound, and the situation may become too stressful for you to handle. One of the best ways of keeping abreast of your flight is to always know where you are. This includes performing time, speed, and distance checks to help you keep track of your progress. Between your last 2 checkpoints, you find that your ground speed has been reduced by 21 knots from your pre-flight estimate. Did the winds change, or did you just miscalculate? After confirming that you didn't miscalculate and that you're still maintaining the planned true airspeed, you should check the winds.
FlightWatch, Cessna 52241, Searle VOR, over.
Cessna 52241, Denver FlightWatch, go ahead.
Cessna 241 is 10 west of Searle VOR, 8,500 at 10, VFR from Grand Island to Cheyenne. Request current winds aloft up to 12,000 between North Platte and Cheyenne.
The current winds aloft indicate the headwinds have indeed increased. Since the winds are just as strong below and stronger above, there isn't much point in trying a different cruising altitude. After calculating your estimated time en route, you find that if the headwinds persist, you'll arrive just in time to make the interview, and your fuel reserve will be reduced to about 20 minutes. You now have an important decision to make. If you continue, you can still make it to the interview on time. After all, you still have 20 minutes of fuel reserve. But what if the winds increase? Or what if your calculations are slightly off? Another option would be to land at an alternate airport and refuel. Wouldn't it be better to arrive a little late than not at all? You could always make a phone call to let the interviewer know of your circumstances and hope he'll understand. What decision would you make in this situation? In this case, you rule out the thought of continuing with such a limited fuel reserve and opt for diverting for fuel. Now you have to decide where to land. As you assess the possible options, you look at your current position and the various airports nearby. Searle Airport, just west of Ogallala, is one possibility, although it's now nearly 15 miles behind you. Chapel is another choice and is almost directly on course. Sydney is also an option, but it is farther away. Because Chapel is the closest airport along your route to Cheyenne, you decide to deviate slightly and land there to avoid depleting your fuel reserve any more than you have to.
Columbus Radio, Cessna 52241, transmitting 122.1, listening Sydney VOR.
Cessna 52241, Columbus Radio, go ahead.
Cessna 241 is 15 west of Ogallala at 15, VFR from Grand Island to Cheyenne. I'm experiencing strong headwinds and I'm going to land at Chapel for fuel. Request you advise Casper Flight Service to extend my flight plan by 1 hour. I'll contact you again as soon as I'm airborne.
Roger, 241. We'll extend your VFR flight plan. Sydney altimeter 299er8.
As you approach Chapel Airport, you feel good about your decision to divert. Because you were doing such a good job monitoring the flight, you detected the headwinds. Thus, you eliminated the possibility of inducing a stressful and potentially dangerous situation had you continued toward Cheyenne with such a limited fuel reserve. There doesn't seem to be anyone around to give you some fuel. In fact, the fuel pump is locked, and the airport seems almost abandoned. Maybe you can call someone to come out and fill you up. The only problem is that there doesn't seem to be a telephone anywhere. How are you going to contact the interviewer to let him know you're running late? If you had taken a good look at this alternate, you would have seen that the airport symbol does not have the tick marks which indicate service is available. This airport happens to be unattended. Let's go back to the decision point and look at some other options. When you made the decision to divert, there was plenty of time to identify the many alternatives available. Although you've already passed Searle Field, the airport does indicate the availability of services. By turning around to divert, the strong headwinds would become tailwinds, and you would be there in no time. Another good possibility is Sydney. It too shows services available, And not only is it safely within range, but it's also directly along your route of flight. You could always contact Sydney Unicom while in the air to make sure fuel is available and that someone is there to pump it for you. With that choice in mind, let's continue ahead and refuel at Sydney.
Sydney Unicom, Cessna 52241, 10 East, 6500, VFR inbound, request airport advisories.
Cessna 52241, Sydney Unicom. The surface winds are 320 at 12 knots, favoring runway 33. A Warrior's in the pattern shooting touch and goes on runway 27, right traffic. Sydney altimeter is 29907.
Again, you have a decision to make. Although the winds favor one runway, another airplane is practicing crosswind landings on the other. Which runway will you use? With the Cherokee in sight, you decide to enter the pattern and follow it in for a crosswind landing. After all, you've had quite a bit of practice, and the wind does not exceed the airplane's maximum demonstrated crosswind component.
Sydney traffic, Cessna 241, entering right downwind, runway 27, following the Cherokee turning final, Sydney.
When you're established on downwind, you begin to notice the strength of the wind because it's taking a fairly substantial crab angle to maintain the proper ground track. As you turn to final, the strength of the crosswind can really be felt. Approaching the runway, you need to apply more crab than you have ever experienced, and you're having a difficult time aligning the airplane with the runway center line. Should you continue the approach or try something different?
Sydney traffic, Cessna 241 is going around runway 27. I'll enter a left downwind for runway 33. I have the Cherokee in sight and will land after it's clear of runway 27.
Your decision for discontinuing the crosswind approach is a very important one. The margin of safety provided during the approach and landing is small. Because your task requirements are highest during this phase of operation, the risk of an accident is also highest. Therefore, if you feel uncomfortable during the approach, break it off. Just because someone else is using the runway for crosswind practice does not mean you have to put yourself in the same risk, especially if you feel that the wind is too strong for your airplanes or your own capabilities.
Well, I picked up some strong headwinds and had to land for some more fuel. I should be there in about 2 hours? Okay, thank you very much. Bye-bye.
After refueling, you climb back to cruising flight and continue toward Cheyenne.
Sydney traffic, Cessna 632, turning final for 33.
Sydney Unicom, Beach Niner 41, North 5.
After passing Pine Bluffs, you pick up the highway and follow it into Cheyenne. About 15 miles out, you begin your descent and start to prepare for the arrival.
Cheyenne Tower, Cessna 52241, 15 East, VFR inbound for landing. Cheyenne Tower, Cessna 52241, 15 East, VFR inbound for landing.
Cheyenne Tower doesn't seem to be answering, since Cheyenne has an operating control tower and is in Class D airspace. You must establish radio communications before entering the area. Therefore, you're going to have to make a decision. You could always land someplace else and have the radio fixed. As you look at your present position, you realize that your options here are pretty limited. Pine Bluffs is close, but the symbol indicates the airport is unattended, so it's unlikely to have a radio shop. Every other choice is at least 35 or 40 miles away. Another possibility is to follow the lost communications procedures by entering the traffic pattern and waiting for light signals from the tower. That choice sounds more feasible, so you continue toward Cheyenne. Before you resign yourself to the fact that the radio is broken, you probably should try to figure out what's wrong with it. In fact, this should have been the first thing you did when you suspected radio failure.
Cheyenne Tower, Cessna 52241. Cheyenne Unicom, Cessna 241, how do you read?
West wind and runway information.
Cheyenne Tower, Cessna 52241, 11 East, VFR inbound for landing.
Cessna 241, how do you read?
Cheyenne Tower, Cessna 241, loud and clear.
Cessna 241, Cheyenne Tower. Enter a right base, runway 34. Wind 330 at 15, altimeter 3001. Report 3 east of the airport.
Cessna 241.
Cheyenne Tower, Cessna 241 is 3 east.
Cessna 241, cleared to land. Caution, wake turbulence, departing DC-9 on runway 26.
Now you have a couple of quick decisions to make. Your first one is which runway to land on. You were initially instructed to enter a right base for runway 34. Now the controller simply cleared you to land. Does this mean you're to land on runway 34 or behind the departing jet on runway 26? Which one would you choose?
Cheyenne Tower, Cessna 241 request clarification. Am I cleared to land on runway 26?
Negative 241, you're cleared to land runway 34. Caution, wake turbulence from a DC-9 which is departing on runway 26.
Cessna 241.
Anytime you're uncertain of the meaning of a clearance, regulations require you to immediately request clarification from ATC. By asking the controller to clarify his instructions, you not only conform to regulations, but also eliminate the risk of conflicting with other traffic by landing on the wrong runway. The next decision you have to make is how to avoid the wake turbulence produced by the departing jet. If you assume the controller's mandatory separation will assure that you'll avoid the wake turbulence, you may be in for quite a shock, because as you near the runway, the airplane becomes difficult to control. So how can you reduce the chance of encountering the wake turbulence? One way is to extend your landing pattern to give the vortices a chance to subside. In addition, you should follow the appropriate vortex avoidance procedures. As you taxi to the ramp, you realize that flying requires a continuous stream of decisions. It's important to recognize when a decision is necessary, then to analyze the situation and determine the best course of action. As a pilot, you must constantly evaluate the interaction of yourself, the airplane, the environment, and the purpose of each flight. This will help you decide whether to start a particular flight, continue as planned, or to make modifications. Here is another example to help illustrate this point. This time, we'll follow a cross-country pilot through the last portion of his flight and see how he uses situational awareness to make some crucial decisions.
There's the reservoir off to the left. At 28 past the hour. So, I should be at Lamar in 15 minutes.
Lamar Unicom, Warrior 81312, 20 southeast, 8,500. Landing Lamar, request wind and runway information for Lamar, over.
Warrior 312 Lamar, the winds are 070 at 10, favoring runway 08. There is a Cessna on the left downwind for runway 08.
Lamar traffic, Cessna 241 is left base for 08 at Lamar, touch and go.
Well, if they're landing on 08, then I'll angle over this direction and set up for the downwind so I can check the traffic before I...
Cessna 241's going around runway 08 at Lamar. Tell me what the winds are doing now.
Cessna 241, Lamar winds are now 350 at 25, gusting 30.
Roger. Stand by. Cessna 241 is switching to runway 35 at Lamar.
That's a fairly drastic wind change. Almost 90 degrees and 20 knots in just a couple of minutes. Those clouds might be building into something nasty. If they are, it'll be a lot sooner than forecast.
Lamar traffic, Cessna 241 is downwind for runway 35, touch and go at Lamar.
If that's a gust front, I may have to think twice about getting into Lamar. But that Cessna must not think it's getting bad enough to full stop. After all, I'm only 10 minutes away. I shouldn't have any problem.
Lamar Unicom, Cessna 241 is left base, runway 35. Wind check, please.
Cessna 241, Lamar winds are now 320 at 35.
Roger, Cessna 241. This will be a full stop.
Sounds like these things are building into full-blown thunderstorms. I wonder if this is going on all around me. I think I'll check another airport.
Stanton County Unicom, Warrior 81312. Request wind and runway information for Stanton County. Over.
Warrior 312, Stanton County Unicom. Winds are light and variable, favoring runway 35.
Roger, Stanton County. Warrior 312. Do you have any thunderstorm activity in the area?
Negative 312. Just a few clouds to the west.
Well, that sounds a lot better.
Attention all Lamar traffic. We have an airplane off the right side of runway 35 about 2,000 feet down the runway. Winds at Lamar are now 300 at 35, gusting to 40.
That settles that. I don't think I want to wind up in the grass at Lamar. I'd better figure out what I'm going to do. I'm right about here. I hate to backtrack all the way to Stanton County. If there's someplace closer to sit and wait this thing out. Springfield's closer. It's unattended, but somebody might be in the pattern who can tell me what the winds are doing.
Springfield traffic, Warrior 81312. Over.
Springfield traffic. This is Warrior 81312. Over.
Well, that didn't work. If I head over to Springfield and find out it's no good, then have to go to Stanton County, that'll take almost 40 minutes, and I can't do that without cutting into my fuel reserve. In 40 minutes, things at Stanton County could turn just as bad as Lamar, and I'd be low on fuel and options. Besides, it looks like the thunderstorms are building up over at Springfield, too. It's a long way back, but I'd better go wait this thing out at Stanton County. At least I know what the situation is there.
Denver Radio, Warrior 81312, listening 116.9er.
Warrior 312, Denver, go ahead.
Roger, Denver Radio, Warrior 81312 has a change to the VFR flight plan. Original destination was Lamar. New destination is Stanton County. Original ETA was 3.
This pilot has just made one of the most difficult decisions a cross-country pilot can make. That is, to turn back along his route and land at a suitable place to wait out some bad weather. By maintaining his situational awareness of the area and applying his knowledge of thunderstorm hazards, he was able to visualize his limitations, make the right choice, and stay out of a situation that exceeded his ability.
Cockpit Resource Management, or CRM, has become a popular subject in the aviation industry. Although it was originally designed to improve crew coordination and efficiency for airline crew members, CRM is no longer limited to the airline, corporate, or commuter multi-crew environment. But what exactly is CRM? Basically, it's the method of making optimum use of the pilot's capabilities, the aircraft systems, and all available resources to achieve the safest and most efficient flight operations. In this program, we'll explore the resources available to you during single pilot operations, such as your personal resources of knowledge, skill, ability, and attitude, as well as external resources such as flight information publications, the pilot's operating handbook and checklist, and the airplane systems. For some time, the FAA has required applicants for practical tests to show competency in selected cockpit management areas. This applies to the private, commercial, CFI, multi-engine, and ATP practical tests. The subject areas here reflect mostly cockpit organization and safety-related items, such as passenger safety briefings and seatbelt usage. However, these subject areas do not fully express the total concept of CRM. In the past, instructors taught only the technical aspects of flying, such as short field takeoff and landing techniques, recovery from stalls, or cross-country procedures. This gave flight training a procedural orientation. Management skills, such as decision-making, organization, and problem-solving, were often missing from the training session. Some students may have been fortunate enough to receive such training, but typically it was covered only briefly and usually in one session. Today, perceptive instructors realize that for CRM to be effective, the training should be included from the beginning and reinforced throughout the training program. This way, the student can develop important CRM skills as well as essential pilot motor skills. Part of the CRM concept is using all available resources in the most effective manner. So, what resources are available to you during single pilot flight operations? You may not realize it, but you carry the most valuable resources around with you every day, namely your own knowledge, skills, and abilities. There's no substitute for knowledge. Aviation, as any pilot or aspiring pilot soon discovers, involves more than just piloting an airplane. There's a vast amount of information that every pilot needs to get around in today's airspace. Airport operations, proper radio phraseology, and meteorology are typical of aviation subjects that require specialized knowledge. Knowledge will also help you in times of emergency. For example, how well do you know your aircraft systems? Could you troubleshoot a problem in flight if you had to? Your knowledge of your airplane systems may prevent a minor inconvenience from turning into a major problem. As a student in training, you are constantly learning some new skill. One of the most important is radio communications. As a pilot, you often need to exchange information effectively and quickly with ATC controllers and flight service station personnel, as well as other pilots. However, communication skills involve more than just knowing the proper phraseology. You must also learn how to listen carefully, and then learn how to get your message across in the most efficient manner. The third personal resource that you have at your disposal is your ability. This involves combining your knowledge and skill and putting them to practical use. For example, making a go, no-go decision for a cross-country based on weather interpretation is an ability. There's one more important aspect of CRM that involves your personal resources: your attitude. The whole purpose of cockpit resource management is to enhance safety. You can be the most knowledgeable, skilled pilot in the world, but unless you have a safety-conscious attitude to match, you're as much a hazard as the less informed, less skilled pilot. Earlier, you were introduced to the 5 hazardous attitudes and their antidotes. Let's take a moment now to review them. Along with your personal resources, you have other resources available to you in the cockpit. For example, your checklist is a valuable asset that should be used for every phase of flight. In an emergency, it ensures that no critical items are overlooked. A current sectional chart provides you with highly detailed information to help you get to your destination. Your airplane's instruments and equipment can also help you reach your destination if you use them properly. Advanced navigation systems, such as GPS, require that you become thoroughly familiar with your particular unit. But once you know how to use it, you have another valuable resource. In addition to items in the cockpit, you have various external resources at your disposal. For instance, a call to FlightWatch can give you current weather along your route. If under radar surveillance, ATC can provide you with radar vectors around weather. If radar is not available and you are lost, certain flight service stations can provide a DF steer to point you in the right direction. You can read about these and other services available to you in the AIM as well as in other flight information publications. Now that you have an idea of what resources are available to you, let's put them together with other decision-making elements. Situational awareness is essentially knowing your condition, the airplane's condition, and your surroundings. A decision-making model known as DECIDE represents a logical method for solving a problem. The letters stand for Detect that a change has been made. Estimate the significance of the change. Choose a safe outcome. Identify plausible actions to control the change. Do something. Then evaluate the effect of the action. Finally, set priorities. During your training, your instructor may have introduced a short priority list, like aviate, navigate, and communicate. Let's try this scenario and combine all that you've learned so far. Assume you're on your way to your final destination, an airport in Class B airspace. You try to establish communications. Nothing. You try again. Still nothing. You need to make a decision. Situation. You're a few miles from Class B airspace and your radio is inoperative. Decide. Radio inoperative. Unable to contact ATC. Must remain outside airspace. Re-establish communications. Follow lost communication procedures. You turn to the emergency checklist. As you know, most general aviation aircraft don't have a checklist for lost communications. Therefore, you must rely on your knowledge of aircraft systems and lost communication procedures. Next, set your priorities. Clear the area and begin a turn to remain outside of Class B airspace. Now you troubleshoot the radio and mic. Check the volume, frequency, the comm panel switches, the mic jack connection, and try the hand mic. Nothing. The last piece of the Decide model is filled in. No response. You decide to divert to an airport in Class D airspace. Quickly determine an approximate heading, ground speed, estimated time en route, and fuel burn to the new airport. Unable to establish communications. Squawk 7600. Using the recommended lost comm procedures in the AIM, check the area for traffic and determine the flow. Assured that you're clear of traffic, join the pattern and look for light signals. You see a flashing green light, meaning return for landing. Acknowledge the signal by rocking your wings. Shortly after, you receive a steady green light cleared to land. Again, you rock your wings. Perform your before landing checklist and prepare to land. Through effective use of your personal and external resources, you've made what could have been a serious situation into a minor inconvenience. In this program, we've discussed some of the resources available to you during single pilot VFR operations and some of the decision-making processes. Keep in mind that cockpit resource management is not a static discipline. Rather, it's constantly evolving, and all pilots can benefit from the increased safety it provides.